Welcome to part 2 of the science video. I know I said I was going to continue the video, but in true Miss Chloe style, I pressed stop instead of pause, which finished the video. So I'm doing another video. So this video is my results. You should only be watching this video if you've already done your own experiment, okay? So in this video, I'm going to show you my results and then I'm going to explain why some things dissolve in water and some things don't. So let me show you my results. So the coffee is dissolved. It's all mixed in. It was like granules of coffee, which is like little solid things, and they've disappeared now, but it has turned the water brown. Salt completely disappeared, so that's dissolved. Pepper, you can still see all the pepper in the water, look. So that didn't dissolve. The sprinkles, you can see all the sprinkles, they didn't dissolve. I knew they wouldn't. And the oil, this is quite interesting actually. Can you see the oil? When I put the oil in, it went in and it made all bubbles in the oil. Then, while I sat and watched it, all those bubbles went to the top, and now the oil is just sitting on the top of the water. So it hasn't dissolved and it's separated from the water as well. So I've recorded those results in a results table. So coffee did dissolve, salt did dissolve, pepper, sprinkles, oil didn't dissolve. I'm now going to try and explain to you why this happens, okay? This is quite difficult to understand, but here we go. So, everything in the world, everything is made up of cells, molecules, okay? These are tiny, tiny little things that we can't see. So, this is an example out of modelling clay. And I'm going to use this to try and help you, try and explain. So this, imagine this is a molecule, and this, a scientist would have to look at this using a microscope. So, you know, a magnifying glass, a really, really strong one of those. And then you would see the molecules that things are made up of. Now, water molecules, well, all molecules have got a positive charge and a negative charge. So, let me just show you. Hang on. Can you see that? So the plus is a positive charge and the minus is a negative charge. You'll see that on a battery. If you've ever seen a battery, there's a plus on one end and a minus on the other. And that's because one end is positive and one end is negative. The best way to explain it is magnets. So if you have ever had to play around with magnets, you will know that sometimes they attract and join together. So if you've got two magnets and you try and put them together, one will suck the other one in. And that's because they attract. Sometimes if you try and put two magnets together, they'll repel. And no matter how much you try and push them together, they go apart. They won't go together. And that's because magnets have a positive and a negative side too. So can you see there? Positive, negative, positive, negative. Now, if you put two things together that are different, so if you put a positive end next to a negative end, it will join together. Okay? And they'll be sucked in together because they attract. If you put a negative end next to a negative end, can you see there? Look, I've changed it now. So a negative end next to a negative end, they won't attract. They'll try and get away from each other. Okay? So they're going to try and go apart now, not together. In fact, those arrows aren't clear there. I've changed my place and I'll put my arrows. So they don't get pulled together. They get sent apart. And the same thing happens with the molecules in each of these things. So, for example, here's my water molecule. This has got positive and negative in it, okay? Now let's imagine that this is my salt molecule. When that gets mixed in with the water, the negative part of the salt molecule join up because it's got more negative in it than positive. And so they attract and it joins up and it all becomes the same thing, okay? And the same has happened with the coffee. So the coffee molecules, they've got lots of negative in them, okay? So they've joined up with the positive charges in the water molecule. And again, they've been sucked together and then they get mixed together to become the same. Now, let's pretend that this bit here of modelling clay is a pepper molecule, okay? So here's my water molecule and here's my pepper molecule. Now the pepper has got lots and lots of positive charge in, the same as the water molecule. And so when they go to join and get together, they quickly shoot apart. And no matter how much they try and join together, they just keep shooting apart. Like two magnets would if you put the same ends together. They would never join up. So I know it's quite hard to understand and it's quite hard to imagine, but that is why. So let me just show you again. The pepper, when mixed with the water, tried to join and it couldn't because pepper's got lots of positive charges in and so is the water. The sprinkles, again, when I put the sprinkles in, the molecules tried to join together, but they couldn't because there's too many positive charges in the sprinkles as well. Now, the oil, the same thing happened with the oil. So, again, I think I don't need to tell you again. Hopefully you understand now what sort of charge the oil has. If you do understand this, if you don't understand it, don't worry. Just do the experiment. And this is something that you'll learn. You probably learn it at high school, to be honest. But I thought I'd try and explain it to you anyway. But if you do understand this and you do understand the molecules and the positive and negative charges, then it'd be great if when you do your results, you could say what it's got more of in it, because you'll be able to see. If it does dissolve, it means it's got more negative charges, so it can join up with the water. If it doesn't dissolve, it means it's got too many positive charges, like the water, so it won't join together. So if you want to be really, really scientific, put that on your results. That'll be impressive. Also, if you want to do a second science experiment, this is the extra challenge. Try using hot water, okay? So do the whole experiment again, but use hot water. If you are going to do the extra challenge, you must get an adult to help you, because you can't use the hot water by yourself because you might burn yourself. So only do the extra challenge if you've got an adult to help you and they need to pour the water in each glass, okay? I hope you had fun doing this. I did. That's been another episode of Science with Miss Chloe. I'll see you next week for the next one. Bye.